Hi, welcome back techies. So in today's video, we will be discussing about that what is machine learning. Okay, so before I start with what is machine learning and all that, I would start that have you ever wondered how YouTube recommend videos, Netflix suggests movies, Amazon predicts what you will buy or ChatGPT understands your question? All of these use machine learning. In this video, you will learn everything about machine learning from scratch. Now, before starting with machine learning, I will start with artificial intelligence because machine learning is a subpart of artificial intelligence. So, a knowledge of artificial intelligence should be must before learning machine learning. So, basically, what is artificial intelligence? So, artificial intelligence is making computers behave intelligently. For example, self-driving cars, Chat GPT, Alexa, Face Unlock, Chess AI, etc. Now,
I'm not quite sure how to help you with that.
I will show you with the hierarchy of AI, machine learning, deep learning, generative AI, and all that. First, we have AI, then we have machine learning, then we have deep learning, and then we have Gen AI. Now, the difference between all of them, what is the difference between AI, machine learning, deep learning, Gen AI? I made a separate video for it. You can just go there and understand that what is the difference between AI, deep learning, and all that. Okay. I would not be focusing on this much. I will be mainly focusing on machine learning. Now comes what is machine learning. So machine learning is a branch of AI where computers learn patterns from data instead of being explicitly programmed. Basically, do you remember what traditional programming were? It were rules plus data which gives answer. Machine learning, we have data plus answer which gives which we give to a model and then it makes prediction. Okay, real life example, spam detection. Instead of writing we train the computer using thousands of spam emails and the computer learns the pattern itself. Now, why machine learning? So without next question is why machine learning? So basically, without machine learning, programmer writes every rule. Impossible when millions of conditions exist. With machine learning, computer automatically learns. Our motive is to make the computer automatically learn. Automatically learn. Example, YouTube recommendation, Instagram feed, Netflix, Amazon, Google search, fraud detection, and face recognition. Here in all these places we use machine learning. Now, in real world application, if I take, basically machine learning is in the field of healthcare, disease prediction, banking, fraud detection, finance, stock prediction, education, student performance prediction, agriculture, crop prediction, e-commerce, recommendation system, transportation, self-driving cars, cyber security, manufacturing, and quality inspection. Now, the favorite part of mine comes types of machine learning. So for that, so types of machine learning. Basically, there are four types of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. But we will be focusing on supervised learning and unsupervised learning and reinforcement learning. I would be writing it here. Supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is whenever we work with labeled data. and unsupervised is whenever we learn with unlabeled data. Okay, basically in supervised learning we have classification and regression. In classification, whenever we classify that a yes or no output is coming, like a mail is a spam and not a spam. So yes, no output whenever it is coming, it is classification, and whenever we are predicting the numerical values, it is regression, like the house price prediction. Okay, so the definition of supervised learning I would give you as input and output are already known. Example, house price prediction and email spam and all that comes into classification. Regression is there, and algorithms, very important thing. I will tell you the algorithms. Linear regression, logistic regression, decision tree, random forest, SVM, KNN, K nearest neighbor is KNN, XGBoost, and naive Bayes. Okay, these are all the algorithms of supervised learning. It can be of both classification, regression, doesn't mind, but it is of supervised learning. Now, we comes with unsupervised learning. Basically, we find hidden patterns over here. We don't have labeled data, so basically we find hidden patterns. Okay, example of this the project which we'll be making is of customer segmentation, and the algorithms are k-means, DBSCAN, PCA, and hierarchical clustering. Okay, now what comes in reinforcement learning is basically you have an agent, environment, reward, and learn. So basically it is a reward type of learning where if the model predicts the correct output, we give it a reward, and that's how we learn. For example, it is used in chess, robotics, games, and self-driving cars. Okay, semi-supervised learning is basically when we work on small labeled data and large unlabeled data. Example is medical images. Now I will tell you the machine learning workflow. Okay, first we have, for any project or all, we have this workflow: problem, statement. Then we collect data. Then we apply data cleaning. Then we do EDA. Then feature engineering. Then what we do? We do feature scaling. Then train, test, split. Train, test, split. Then we choose algorithm, which algorithm we do use. Then we train the model. Then we evaluate our model. Then hyperparameter tuning. Then what we do? We do deployment. Then we do the monitoring. Okay, so this is like the pipeline of a machine learning project. Now, if we see a data set, we will have some rows, columns. Rows are the targets and columns are the features. I will like tell you. We have age over here. We have salary over here. And we have purchased over here. Age is 25, 30, 40,000 and it is 70,000, and purchase, no, it is yes. So basically these are the rows are the targets and salary, purchase are the features. Okay, so basically features are the target variable and the basically we have the features, target variable, independent variable and dependent variable. Age and salary are the independent variable and purchase is the dependent variable where it is dependent on these two. Okay, so it is something like that. Now I will tell you data pre-processing. Data pre-processing is one of the very important and crucial step in machine learning project. What happens in data processing? We handle the missing values. See, every project, every data set we will get will always not be like it will containing some missing values, some null values. We have to all adjust all that. That comes under data pre-processing. There we handle the missing values, we handle the duplicate values, we do the encoding, we do the scaling, normalization, standardization, outlier, data cleaning. We handle everything. Okay, then we do EDA. What is EDA? Exploratory data analysis is called as EDA. Why EDA? Because we have to understand the data, find the trends, detect the outliers, visualize, draw the graphs, histograms. In here, we have many types of graph like histogram, box plot, scatter plot, heat map, bar chart, pie chart. I've separately made the library a video matplotlib library. Inside that I've explained all this chart. You can just go there and see. Next we do is feature scaling, feature and engineering. Inside that we do feature selection, feature extraction, creating new features, encoding and scaling. Then we have our train test split. Basically if our data is from 1 2 3 to like 100 till 80 we use for training our model, and from 80 to 100 we use for testing our model. We make our X train, Y train. X is for independent feature and Y is for dependent feature. We make separate training and testing data for it also. Okay, now we have machine learning algorithms. We have many machine learning algorithms, and some I would name it: linear regression, logistic regression, decision tree, random forest, KNN, naive Bayes, SVM, XGBoost, gradient boosting, ADA boost, light LGM, cat boost, neural networks. For we have like, for all these algorithms, I would be making a separate video for you, because if in this video I would be explaining all these things. For every algorithm, there would be a problem, working, advantages, disadvantages, and real application. Done. I will make a separate playlist for all this algorithm. Next, we have classification versus regression. So basically, in classification, we have like our output cat, dog is there, spam, not spam is there, and regression, we have our output as price, temperature, and salary. So basic difference between classification and regression, you can see that in classification, you have like yes or no kind of thing, and in regression, you always have numeric output. Now, we comes to basically like we have model evaluation. In that, you have regression matrix, MAE, MSE, RMSE, R square, classification matrix, accuracy, precision, recall, F1 score, confusion matrix, ROC curve, AUC. Everything is there, and I have explained all this in the project. So also you can just see that, and you can understand that all the model, how a model is evaluation. Then comes our overfitting versus underfitting. So basically, this is one of the most asked interview question. You can like, you have like in this underfit, good fit, overfit, how to avoid overfitting. Overfitting is a separate topic I would be covering. Next, we have basically our how we deploy. We deploy basically, we train the model, same model, we use Flask, fast API, website, users we have, and like that. So in a complete real project, we first take the data set, then we do the EDA, cleaning, feature engineering, scaling, model evaluation, and deployment. Next, we have libraries. There are around many libraries: NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, TensorFlow, PyTorch, XGBoost, LightLGM, and SkyPy. These are the main libraries, and the good thing is that I have made a separate playlist explaining each and every library I have mentioned right now over there. You can just go to that playlist and understand all these libraries. So this was all about machine learning, and congratulations, you now understand the complete machine learning pipeline, from what machine learning is to build, evaluating, and deploying models. The best way to master these concepts is by building projects. On this channel, you will find step-by-step tutorials on Python like NumPy, Pandas, Matplotlib, TensorFlow, PyTorch, and many complete machine learning projects. If this video helped you, like, share, and subscribe, and let me know in comments which topic you would like to learn next. Okay, so thank you everyone.